All right, welcome back to the deep dive. You know how this works. You send us the stuff that you wish you had time to read, and we do the heavy lifting. We break it all down.
That's right. Get to the good stuff.
Exactly. And today we're diving into the world of hydrodynamic bearings,
Oh, yeah.
specifically tilting pad bearings. And you sent over a fantastic resource from the folks at Kingsbury.
Universebrochure.pdf.
Yeah. Universebrochure.pdf.
Yeah.
Now, these bearings are like the unsung heroes. They're the silent workhorses of the mechanical world.
Absolutely.
They keep everything running smoothly.
Yeah, you don't think about it, but
You don't. From giant turbines in power plants
Right.
to car engines.
to everything. Yeah. I mean, it's really amazing how crucial bearings are to pretty much all modern technology, and we never even give them a second thought.
We take them for granted. It's like power plants, spaceships, everything. Okay, but what are hydrodynamic bearings? How can just this thin film of oil actually support so much weight? It's like magic.
It is a little bit like magic, but it's really clever engineering. Imagine a puck gliding across an air hockey table. That's sort of what's happening here, but instead of air, we have this super thin layer of oil, only about 1/1000th of an inch thick.
Wow.
And as the shaft rotates, it drags this oil along, creating a wedge of pressure that keeps the metal surfaces from ever actually touching.
So it's like, are we talking about like a controlled hydroplaning?
Yeah,
So instead of losing control of your car on a wet road, you're harnessing that slippery effect, but in a controlled way.
that's a great analogy. And, there are different types of bearings out there, but today we're focusing on hydrodynamic tilting pad bearings. What makes these special is they're self-lubricating, so the shaft's motion actually does the work, and those tilting pads, they adjust to changes in load and speed, making them incredibly efficient.
And this brochure mentions a guy named Albert Kingsbury who invented the tilting pad thrust bearing. This guy sounds like he really had a light bulb moment that changed everything.
Absolutely. His invention was huge. It revolutionized shipbuilding. Just imagine ships suddenly becoming faster and more fuel efficient.
Wow.
It also solved a major problem in those early hydroelectric plants.
Wow.
It made them way more reliable.
And speaking of hydroelectricity, there's a really cool story about the Holtwood generating station. I think it was back in 1912. They installed the first tilting pad bearing there, and it actually failed initially.
Oh, no.
Can you believe that?
Wow.
But they stuck with it. They figured out what went wrong, and that same bearing ended up running for 75 years.
That's incredible.
75 years.
That's just amazing. That's a perfect example of, learning from mistakes, right?
Yeah.
Failure can lead to incredible breakthroughs. Can you imagine the engineers' faces when that bearing just kept going and going? Talk about exceeding expectations.
Totally. All right, so we've got this thin film of oil magic happening.
Yeah.
But can we break it down a little further? Like, what are the actual parts of these bearings? I'm picturing it like a high-tech sandwich in my head, but maybe that's just me being weird.
No, that's a pretty good analogy. Let's start with the rotating collar or the journal. That's the part that's attached to the shaft. And this has to be incredibly smooth. We're talking like a mirror. For that oil film to do its job, we're talking smooth on a microscopic level.
Really?
Yes.
Wow. So then we have the thrust shoe or journal shoe assembly. Is that the part that actually rides on that thin film of oil?
Yes, exactly. And the shoe is actually made up of several layers. You have the babbitt, which is a layer of soft, high-tin metal. It acts like a sacrificial layer. It protects the collar from damage. And it even embeds any little contaminants that might be in the oil, keeping things nice and clean.
So the babbitt's like the built-in bodyguard for the collar.
Pretty much, yeah.
Yeah.
And then you have the shoe body, which supports the babbitt and allows it to tilt.
Okay.
And finally, the pivot, that's the part that enables the shoe to create that crucial wedge shape that makes the whole hydrodynamic effect work.
So it's like each shoe is this tiny little seesaw that's constantly adjusting to find that perfect balance.
You got it. And then to hold all these shoes in place, you have the base ring, which not only secures them, but also allows them to pivot and often channels the oil supply as well.
Interesting. And what about those leveling plates that I see in this diagram? They look pretty intricate.
Yeah, they're a really brilliant piece of engineering, specifically found in thrust bearings. You can think of them like a self-adjusting system.
Yeah.
They distribute the load evenly across all the shoes, even if there are like tiny imperfections or misalignments.
So it's not just about perfect manufacturing, but also designing for the real world.
Yeah.
Where things aren't always perfectly lined up.
Exactly. And of course, we can't forget about the oil itself. It's more than just a lubricant. It's really the lifeblood of the bearing. It keeps everything cool, prevents wear, and we'll dive into the fascinating world of lubrication a bit later.
Okay, so we've talked about the parts.
Yeah.
Now let's see how those parts need to work together
Right.
perfectly.
Absolutely.
So we need to consider things like tolerance, alignment, and what was that other term?
Equalization.
Equalization, yeah.
It's all about making sure the load is distributed evenly across the bearing surface. Even the tiniest manufacturing imperfections can have a big impact on performance. That's why those leveling plates we talked about are so crucial.
That's all about balance,
Yes.
making sure all the parts fit together just right. Now, what about the space between them?
Oh,
Is that important too?
absolutely, yeah.
Yeah.
We call that end play and radial clearance. And,
Uh,
it's kind of like the Goldilocks situation. You don't want it too tight. You don't want it too loose.
just right.
Just right. You need enough space for everything to move freely and expand without things getting jammed up.
Okay, so we got the Goldilocks zone.
Yeah.
Then there's preload,
Preload.
which sounds like something you would do before a workout, but I'm guessing it has a different meaning here.
Yeah, it does. Preload is mainly for journal bearings,
Huh?
and it refers to the curvature of the shoe and how that affects the bearing's thickness and damping. You can think of it like shock absorbers in a car.
Mm.
It allows engineers to really fine-tune how the bearing responds to vibrations.
Oh, so it's all about controlling those tiny movements
Yeah,
and making sure the bearing stays stable, even under stress.
exactly. But even with all of these finely tuned components, it really all comes down to that thin film of oil.
Right.
How do we keep it flowing and doing its job effectively?
Yeah, let's dive into lubrication. It seems like it's more than just pouring some oil in there and calling it a day.
Oh, much more. There's a whole science to it. There are different methods like flooded lubrication, pressurized lubrication, and directed lubrication.
Mhm.
And then you have Kingsbury's really groundbreaking leading-edge groove technology.
Okay. Leg technology.
Yeah.
I'm intrigued. Tell me more about this leg technology.
Well, so leg technology is really clever. Instead of just sort of bathing the whole bearing in oil, it injects cool oil directly into the thin film between the shoe and that rotating surface.
So it's like giving the bearing its own little oil IV drip. Why go to all that trouble? What are the benefits there?
Well, for one, it reduces the amount of oil needed overall, which means less energy is wasted churning all that oil around, so the bearing's more efficient. But the really clever part is that it keeps the shoe surface cooler.
See, I always think of oil as being, slippery, but I never really thought of it as a cooling agent. Why is that so important?
Well, think about what happens when you rub your hands together really fast.
Yeah.
They heat up, right? The same thing happens in a bearing. As that oil heats up, it gets thinner, and that can affect its performance.
Ah, so the oil is losing its grip.
Exactly. But with leg, that cool oil injection, it creates a thermal barrier, kind of like a little air conditioner for the shoe.
Oh, interesting.
Keeps it cool and prevents that viscosity drop. And this means lower operating temperatures, increased load capacity, and a much happier, longer-lasting bearing.
Wow. I'm starting to see why these tilting pad bearings are such a big deal. They really solved a lot of problems that plagued those earlier designs.
They did. And, all this talk about lubrication reminds me of another crucial point in this brochure oil analysis. It's like a blood test for your bearing. It gives you a peek inside, even if everything looks fine from the outside.
Okay, so instead of just checking the oil level, we're sending it to a lab. What kind of secrets can oil spill? What are we looking for?
A lot. Well, for one thing, wear metals. If you see high levels of iron or copper or tin in the oil, it's a sign that your bearing might be wearing down,
Yeah.
leaving a trail of, microscopic metal breadcrumbs.
Oh, wow. That's some serious detective work. Well, what else can we learn?
Well, it can also show contaminants, things like water and dirt, which can really damage the bearing. So it's not just about how much oil you have, but the quality of that oil, too.
Yeah. So it's like making sure you're using the right kind of motor oil in your car. You use the wrong kind, it's going to cause problems.
Exactly. Oil analysis also looks at the oil's viscosity, its thickness, and its chemical makeup. It tells you if it's healthy and doing its job, lubricating those surfaces properly.
So oil analysis is really about being proactive,
Yes,
catching those potential issues before they turn into major meltdowns.
precisely. It's a powerful tool for preventative maintenance.
Okay.
This brochure also stresses the importance of understanding operational data when you're troubleshooting bearing problems.
Okay, I'm all about prevention, but what kind of data are we talking about here? What should we be keeping an eye on?
We'll think about things like load changes, how fast the shaft is spinning, temperature trends, vibration levels, and even the bearing's maintenance history.
So it's about looking at the whole picture.
Yes.
Not just the bearing in isolation.
Exactly. A bearing problem might be a symptom of trouble elsewhere in the machine. For example, imagine a bearing's running hotter than usual. Maybe the oil's low or maybe it's dirty. But it could also mean that the shaft is misaligned or something's off balance in the machine itself.
So it's like a puzzle.
Yes,
We need all the pieces to understand why the bearing is acting up.
that's a great way to put it. By looking at this operational data, we can narrow down the possibilities and find the root cause, like a detective, solving a case.
We've talked a lot about the bearing surface and the oil, but what about that surface that the oil is actually riding on? The collar or the runner or journal. Is it just a smooth surface or is there more to it?
Well, it needs to be incredibly flat, too. And this brochure really goes into detail about why that's so important. Imagine you have a collar that's warped, even slightly. As it rotates, it creates uneven pressure in that oil film, and that can lead to all sorts of problems.
Okay, so smooth and flat. It sounds like even tiny imperfections can really throw things off balance. What kind of trouble are we talking about?
Well, that uneven pressure can cause the shoes to wear down unevenly, making the bearing less efficient and shortening its lifespan.
Okay.
And it can also cause vibrations, which can damage other parts of the machine.
So a slightly wonky collar can have ripple effects through the whole system.
Exactly. That's why inspecting that collar during maintenance is so important. You have to make sure that it's still within tolerance and flat as a pancake.
What if it's not? Is it game over for the collar or can you actually fix it?
Well, sometimes you can refinish it to restore the flatness,
Okay.
but if the damage is too bad, you'll probably need a new one.
Gotcha.
But it really highlights how even a seemingly simple component can have a crucial role in the overall performance.
It's like a chain reaction. If one part's off, it can affect the whole system. Speaking of parts, this brochure mentions split runners, which sounds like something out of a sci-fi movie.
Split runners are basically two-piece collars. They're bolted together around the shaft,
Okay.
and they're common in larger machines where it would be really difficult to fit a solid collar.
Ah, so it's a practical solution. Kind of like those ships they build in sections and then weld together.
Exactly.
But are there any downsides to using a split runner?
Well, one potential issue is fretting corrosion.
Right.
You remember that reddish iron oxide we talked about earlier?
Yes.
Because the two halves of a split runner are bolted together, there's always a chance of tiny movements between them, and this creates like the perfect conditions for fretting corrosion to form.
So easier assembly, but higher risk of corrosion.
Yeah, that's the trade-off.
Yeah.
That's why inspecting split runners for fretting is key during maintenance.
Okay.
Prevention is the best medicine, making sure that those two halves are perfectly aligned and tightened. But if you do find fretting, you can try to clean it up and apply a protective coating to prevent further damage.
Again, it's all about those little details. This brochure also mentions cavitation,
Cavitation.
which sounds kind of scary. What exactly is cavitation?
It's the formation and collapse of vapor bubbles in a liquid. Think of like the bubbles that form in water when you stir it really fast.
I can picture that. But how does that affect a bearing?
Well, in a bearing, cavitation happens in spots where the oil pressure drops suddenly, like at the trailing edge of a shoe, for example. And when those vapor bubbles collapse, they create tiny shock waves that can damage the bearing surface.
So it's like those sinkholes that suddenly open up in the ground,
Yeah,
but on a microscopic scale.
that's a great analogy. And cavitation can be tricky to diagnose because the damage can look very similar to other types of wear.
So how do you know if cavitation is the culprit?
Well, location is key. Cavitation tends to occur in very specific zones, like that trailing edge of a shoe or near the outlet of an oil groove. If you see damage in those areas, it's a good bet that cavitation's the cause.
It's like those crime shows where the detectives are looking for patterns at a crime scene.
Exactly. And just like in those crime shows, there are ways to prevent this villain from striking.
Okay, I'm all ears. How do we stop cavitation from happening?
Well, you need to make sure you have a smooth and steady oil flow without any sudden pressure drops. Think of it like a lazy river, no rapids allowed.
Okay.
You can also increase the oil pressure or viscosity to help prevent those bubbles from forming in the first place.
So it's all about creating this calm and controlled environment for that oil.
Exactly. And this brings us to the importance of the bearing's design.
Okay.
It's not just about maintenance and troubleshooting. The initial design of the bearing plays a huge role in how well it performs and how long it's going to last.
It's like building a house.
Right.
A solid foundation is crucial no matter how well you maintain it later on.
That's a great analogy.
Yeah.
And that's where the expertise of bearing manufacturers like Kingsbury really shines. They have the knowledge and experience to design bearings that are optimized for specific applications.
So it's not a one-size-fits-all situation. You need to consider the load, the speed, the temperature, everything.
Precisely. Working with a bearing manufacturer is like getting a custom-tailored suit
Oh, I like that.
for your machine.
Okay.
It ensures that you get the perfect fit for your needs.
So we talked about the collar, the oil, the design.
Hmm.
What about the materials themselves? Is it all just steel and babbitt?
Well, the shoe body is usually made of steel
Okay.
for strength and durability.
Okay.
But sometimes bronze is used, especially when corrosion's a concern. It all depends on the environment where the bearing is going to be operating.
So choosing the right material is like picking the right outfit for different weather conditions.
Exactly.
You wouldn't wear a swimsuit to climb Mount Everest.
You wouldn't. And, this brochure has a fascinating little tidbit about using chrome copper
Okay.
to keep babbitt temperatures down.
Chrome copper. That sounds like something Iron Man would use.
It does sound pretty high-tech, but it's a special alloy that's a rock star at conducting heat.
Okay.
So by using it in certain parts of the bearing, you can dissipate heat more efficiently and keep that babbitt nice and cool.
So it's like adding a little heat sink
Yeah,
to the bearing, like the things they put on computer chips.
precisely. And this leads to all sorts of benefits, like the bearing being able to handle heavier loads and lasting even longer. It's a great example of how material science can really boost performance.
It's amazing how much science and engineering goes into these seemingly simple components. We've talked about different ways that bearings can wear down, but are there any other red flags that we should be aware of when we're inspecting these things?
Oh, absolutely. There's one called wiping, and it's not a pretty sight. Imagine the oil film failing and those metal surfaces start grinding against each other.
Ouch. That sounds like a recipe for disaster.
It is. It can happen for a few reasons.
Bro.
Not enough oil, too much weight, misalignment. And when it happens, the babbitt will have this shiny, smeared look, almost as if someone tried to polish it with sandpaper.
So if you see wiping, it's a pretty clear sign that something's seriously wrong.
Definitely. If you see wiping, you need to address the root cause as soon as possible to prevent further damage.
So how do we tackle this wiping problem?
Well, first you need to play detective and figure out why the oil film is breaking down.
Right.
Is it a lubrication issue?
Yeah.
A mechanical problem? Once you've found the culprit, you can take action. Maybe adding more oil or fixing a misalignment.
So it could be a simple fix or a major overhaul depending on the cause.
Exactly. And this just emphasizes the importance of those regular bearing inspections that we talked about. Catching these issues early is key to preventing catastrophic failures.
It's like going to the dentist for regular checkups so you can avoid those root canals.
That's a good way to put it.
Okay.
During inspection, check the oil level, check the oil quality, look for signs of wear like scratches or discoloration on the bearing surfaces, and examine the overall condition of the housing, bolts, and lubrication system.
So it's like a full body checkup
Yes,
for the bearing, making sure everything is in tip-top shape.
precisely. And don't forget about documentation. Keeping detailed records of inspections and maintenance is really important.
So we need to keep a journal for our journal bearings.
Yeah, something like that.
Why is good documentation so important?
Well, it helps you track the bearing's condition over time. It's like a medical history.
Okay.
It can reveal any patterns or trends that might signal a problem brewing beneath the surface.
So we can spot those red flags before they become major emergencies.
Exactly. And if a bearing does fail, those records can help you understand why, so you can learn from it and prevent the same issue from happening again. It's also a great tool for troubleshooting.
Like having a breadcrumb trail to follow.
Yeah,
Back to the source of the problem.
exactly. Good documentation is like having a superpower when it comes to bearing maintenance.
Speaking of superpowers, what about the people who are actually doing these inspections and repairs? I'm guessing you don't want just anyone tinkering with these complex systems, right?
You're right. Training is absolutely crucial. Bearings are intricate, and it takes knowledge and experience to handle them properly. Investing in training for your maintenance personnel is really an investment in the long-term health of your equipment.
So it's not just about having the right tools and the right lubricants. You need the right people with the right skills.
Precisely.
Yeah.
And along with training, good communication is vital.
Okay.
Everyone involved, operators, maintainers, repair technicians, they all need to be on the same page.
It's like a well-oiled machine itself.
Exactly.
All the parts working together smoothly.
Exactly. When everyone's communicating openly and proactively, it's so much easier to prevent problems in the first place. And then if they do arise, to solve them quickly.
It sounds like we've covered a lot of ground here.
We have.
But I have a feeling this is just the tip of the iceberg when it comes to bearing maintenance.
Yeah, you're right. There's always more to learn, but this deep dive has given us a really solid foundation to build on.
And speaking of building, this brochure touches on some really exciting new technologies for improving bearing performance. Where are things headed in the future of bearings? What's coming next?
Well, buckle up. We're seeing huge advancements in material science. Things like super strong ceramics and composites that can make bearings lighter and stronger and more resistant to wear and tear.
Those sound like materials they use in spaceships.
They do. And then we're also seeing cool new lubrication technologies, like
Yeah.
solid lubricants and self-lubricating materials. That could eventually eliminate the need for traditional oil or grease altogether.
Wow, that sounds like something straight out of a sci-fi movie.
It does. And then there are new sensor technologies that can monitor bearing performance in real time. It's like having a tiny little doctor inside the bearing itself.
Oh, wow.
These sensors could detect potential problems before they even cause a hiccup.
So we're talking about bearings that can practically diagnose themselves.
That's right. All these advancements are making bearings more reliable, more efficient, and more sustainable. It's a really exciting time to be in the bearing world.
It sounds like bearings are only going to become even more important as technology continues to advance.
They will.
Ah.
And that brings us back to something we talked about earlier, the importance of understanding those fundamental principles of how bearings work.
Right, because no matter how fancy those materials or sensors get, the basic principles of bearing design and operation, those stay the same.
Exactly. Having a solid understanding of those principles gives you a strong foundation to build on, no matter what new technology comes along.
So it's like learning the alphabet before you can write a novel. You need those basic building blocks.
Precisely. And you know, this deep dive has really highlighted the incredible complexity and ingenuity that go into these seemingly simple components.
I know, right? We've learned so much, it's almost overwhelming.
I agree. I think our listener might be feeling a bit overloaded with information too. Let's try to distill everything we've covered into some key takeaways.
That's a great idea. Let's break it down into some manageable chunks.
I think we can start with just the basics of bearing design and operation. What are the absolute essentials our listener needs to remember about how these things work?
Well, first and foremost, hydrodynamic bearings rely on that super thin film of oil to support the load and reduce friction.
Exactly. And remember, that oil film is generated by the rotating shaft dragging the oil along and creating that wedge-shaped pressure zone we talked about.
And they also need to understand the different parts of a hydrodynamic bearing, the shaft, the housing, the liner, the lubrication system, all those different parts working together in harmony.
Perfect. So that's our foundation. What's next?
Lubrication. We've learned that it's so much more than just keeping the oil at the right level.
Absolutely. Our listener needs to understand why using the right type of lubricant is so important, and why keeping that oil clean and monitoring its condition is essential for bearing health.
Okay, so we've covered design and operation, we've tackled lubrication. What's our third key takeaway?
Inspection and maintenance. Even the best designed, well-lubricated bearing needs regular attention to keep it running smoothly.
Right. Our listener needs to understand why those inspections are so important, what to look for, and how to prevent problems before they cause major headaches.
Exactly. So those are our three main areas: design and operation, lubrication and inspection and maintenance.
It's like a three-legged stool. You need all three legs for a stable and happy bearing.
I like that analogy. And I think if our listener remembers those three key areas, they'll have a solid understanding of the world of hydrodynamic bearings.
I agree. But, even with all this knowledge, things can still go wrong. And we can't leave our listeners stranded if they encounter a bearing issue in the real world.
You're right. We need to equip them with some troubleshooting skills.
Okay, so let's say we're out in the field and we think we have a bearing issue. Where do we even begin? What are our first aid essentials? What are the basics when it comes to troubleshooting these things?
Well, just like a good detective, the first step is gathering information. What exactly is the bearing doing that's out of the ordinary? When did it start? Has anything changed recently, like in how the machine's being used or the environment it's operating in?
So it's like taking a patient history, but for a machine.
Yeah, exactly. And just like with a medical history, checking past maintenance records and operational data, that can be incredibly helpful. Is this a sudden change or has it been gradually getting worse over time? That can really point you in the right direction.
This brochure mentions using operational data for troubleshooting, but I'm a little fuzzy on what that actually looks like. Can you give me some real-world examples?
Sure, let's say you have a bearing that's running hotter than usual. Looking at the past temperature data can tell you if it's a sudden spike or a gradual climb. A sudden jump could mean a lubrication problem, maybe some contamination got in there, or a sudden increase in the load it's carrying.
So knowing the context is key.
Absolutely. A gradual increase over time might point to wear and tear, or maybe a problem with the cooling system. And don't forget about vibration data. If vibration is increasing along with the temperature, well, then you might be dealing with misalignment or an imbalance in the rotating parts.
It's like putting together a puzzle.
Yeah,
Each piece of data gives you another clue.
exactly. And let's not forget about the bearing's maintenance history. Has it been serviced recently? Were any parts replaced? That kind of information can help you pinpoint the source of the problem a lot faster.
It's like having a detective's notebook, piecing together all the clues to crack the case of the troubled bearing. This brochure also has this whole section on distress modes, which is fascinating. It's like a forensic analysis of everything that can go wrong with these bearings.
It is. And we've talked about some of the usual suspects, abrasion, tin oxide damage, overheating. But there are some less common but equally important culprits out there.
Give me the rundown. What are some of these lesser-known bearing villains?
Well, have you ever heard of electrical pitting? It's not as obvious as, say, a scratch or a dent, but it can be just as damaging.
Electrical pitting. I don't think I've heard of that one.
Imagine tiny little lightning bolts zapping across that microscopic gap in the bearing. That's essentially what electrical pitting is. It creates these tiny pits in the babbitt, which eventually lead to wear and tear and premature failure.
Wow, so even electricity can be a threat to these seemingly simple mechanical components.
You can. And then there's fatigue, which is like, bending a paperclip back and forth until it snaps. It's cracking and spalling caused by repeated stress, often due to misalignment, imbalance, or vibration.
So even those tiny stresses can really add up over time.
They can. And then you have some even sneakier culprits like erosion, where bits of the babbitt are literally carried away by obstructions in the oil flow. And corrosion, which is basically a chemical attack on the babbitt, often caused by contaminated oil.
Sounds like keeping that oil clean is absolutely crucial.
It is. And this brochure really drives home the importance of not just checking the oil level, but actually analyzing its composition. Things like particulate density, viscosity changes, even signs of chemical breakdown, those can all reveal hidden problems.
So the oil isn't just a silent partner.
Right.
It's actively communicating how the bearing is doing.
Exactly. It can reveal where metals, contaminants, even signs of oil breakdown that you wouldn't be able to see just by looking at it. It's like the oil is telling a story about the bearing's health.
This is making me think I should send a sample of my car's oil to a lab for analysis.
That's not a bad idea. While this brochure doesn't focus specifically on cars, the fundamental principles apply to bearings everywhere.
Right. Whether it's a massive turbine in a power plant or the crankshaft in your car engine, those hydrodynamic bearings are silently working their magic, keeping things moving smoothly.
And the more we understand about them, the better equipped we are to take care of them and ensure they have a long and productive life.
This has been an incredible deep dive. I feel like we've gone from zero to bearing heroes, armed with all this knowledge about their design, operation, and even how to troubleshoot them when things go wrong.
Me too. And it's a good reminder that even everyday objects, things we take for granted, can be incredibly fascinating when you take the time to really explore them.
So, dear listener, what does this all mean for you? You now have a treasure trove of knowledge about these unsung heroes of the mechanical world, hydrodynamic bearings.
You know how they work, what can go wrong, and most importantly, how to keep them happy and spinning smoothly for years to come.
So the next time you hear a machine hum, just think about that invisible film of oil, silently doing its job thanks to the ingenuity of engineers like Albert Kingsbury and countless others who've contributed to this vital technology.
And if you ever face a bearing problem, just remember those key troubleshooting steps. Gather information, narrow down the possibilities, and develop a plan of action, always keeping safety top of mind, of course.
And don't hesitate to call in the experts. Bearing manufacturers like Kingsbury, they have a wealth of knowledge and resources to help you solve even the trickiest bearing mysteries.
They're always happy to share their expertise and help you keep those bearings running smoothly.
Well, that wraps up our deep dive into the fascinating world of hydrodynamic bearings. We hope you've enjoyed the journey as much as we have.
Until next time, stay curious.